People have been hating on the internet computer for years. They've called it centralized garbage, another Solana, and just a VC scam that will die off in the bear market. But it's still here. And not only that, the community and ecosystem on it is growing rapidly. In fact, the team behind hasn't stopped building during the bear market, going as far as recently announcing that they've built sophisticated AI systems on top of the internet computer. So were all the fodders correct on ICP, or is ICP the next big thing in Web3? I'll be going through everything you need to know about it, including the tech, tokenomics, and my price predictions on it. Let's get into it.
This video is not financial advice. Read disclaimers on the screen.
I want to start this video off by saying this is not financial advice. Once again, read the disclaimers I just showed. This is purely educational and meant to inform you about what I believe the internet computer is. But what exactly is it? Well, the internet computer redefines the fabric of the internet with its groundbreaking technology. Unlike traditional blockchains, it employs a novel protocol and architecture designed for speed, scalability, and security. But how exactly does it achieve this? Well, let's break it down. At its core, the internet computer is powered by a network of independent data centers across the globe. Keyword data centers, and we'll get into that a little bit later, but these data centers run specialized hardware to support the internet computer protocol, which is what they use to connect to each other over the internet. And using the ICP protocol, or the internet computer protocol, these data centers connect up and form a public world computer. So far, this is not too different from other blockchain platforms. I mean, Bitcoin and Ethereum are also fundamentally just a bunch of computers around the globe being connected to each other via a protocol. But here's where things start to differ. So unlike traditional proof of work and proof of stake mechanisms, the internet computer utilizes a novel consensus model known as chain key cryptography. This does quite a few things, but firstly, this splits the consensus process into two layers, one for update calls and one for query calls. You can think of update calls as a transaction that changes the state of a smart contract. So for example, if you build a decentralized social media platform on top of the internet computer and you send a transaction to send a new post on your profile, that would be a update call. Sending tokens as well is an update call. So for the most part, you can just consider update calls transactions, and they completely finalize in 1 to 2 seconds on the internet computer. Query calls are just retrieving information from the internet computer. So let's say you load up someone's profile on this decentralized social media site, that would be a query, and that will happen in milliseconds. And splitting these two things up is what allows the internet computer to actually compete with Web 2 when it comes to speed. Chain key cryptography as well also allows for all these different parts of the network to effectively communicate with each other as well. And that brings me perfectly into the next part we're going to explain, which are subnets. So to achieve unbounded scalability, the internet computer organizes its network into subnets. Each subnet is a group of nodes that can process transactions and run smart contract code independently. So instead of thinking about the internet computer as just one big chain, you can think about it as just a bunch of smaller networks. And this structure allows the entire internet computer to scale horizontally by just adding more subnets over time, enabling it to handle any amount of computation and data storage. But obviously, if the internet computer was just a bunch of small networks that were acting independently, it wouldn't be a world computer. It would just be a bunch of small networks, and it wouldn't have really solved any issues, which is where something called the network nervous system and also chain key cryptography comes in to save the day. So the internet computer network is made up of a bunch of subnets, but there's one subnet on there called the master subnet, and this runs an advanced DAO, decentralized autonomous organization, called the network nervous system. And this basically controls the entire internet computer network. The network nervous system is used to securely upgrade the internet protocol. It's also a governance system, so people can put up proposals and people then vote on those proposals through the network nervous system, but it also instructs nodes how to structure the network. And it does this by telling nodes exactly how to combine to form the subnet blockchain securely. And it does this all once again using the power of chain key cryptography to securely get those messages across. But it's not just the master subnet running the network nervous system that is communicating with all of these subnets. These subnets can also communicate with each other using chain key cryptography as well. So just to recap, the way I understand the internet computer is that you have the brains of the internet computer, aka the network nervous system, running on this master subnet, and this just controls the entire network. And then you have chain key cryptography, which is a technology that allows for all of these different networks to basically act as one unified network, aka a world computer. And users also use chain key cryptography to interact with the network in a very fast and efficient manner. Lastly, we have canisters. canisters, which are the Internet Computer's version of smart contracts. So on Ethereum, you write smart contracts on Solidity and then just deploy that code onto Ethereum. It works a little bit differently in the Internet Computer, and I'll let the CEO Dominic Williams explain them to you.
The Internet Computer reimagines software as interoperable compute units called canisters. Software canisters are an evolution of smart contracts. They consist of a bundle of WebAssembly bytecode and the memory in which that bytecode runs. Just like smart contracts, canisters are tamper-proof and unstoppable. However, a key difference is that they are also scalable and parallelizable. Canisters also run at web speed and are highly efficient. As you would expect, they are open and interoperable. That means that if you create a canister using the Rust programming language and share some functions with me, and I create a canister using the Motoko programming language, my Motoko code can call your functions directly.
And the cool thing about canisters is its native ability to serve web content directly to the user. And also through chain key cryptography, these canisters can actually interact with and communicate with smart contracts on blockchains like Ethereum, and even sign and do transactions on blockchains like Bitcoin. So you can build DeFi systems on top of the Bitcoin blockchain now using the Internet Computer, but also this solves a very important issue in the crypto space, which is the issue of centralized front ends. The entirety of DeFi is actually really centralized because in order to interact with the underlying Ethereum smart contracts running the DeFi applications, you firstly need to go through these front ends, aka uniswap.org, the actual website. And these websites right here aren't built on top of Ethereum. They're built on top of centralized servers, and they just connect you to the Ethereum smart contracts. So using the Internet Computer, you can actually just make decentralized website front ends for all of these applications, and the Internet Computer could actually really help Ethereum by creating a decentralized web experience for it. Okay, now this is the last thing I promise. So we need to talk about the use cases for the actual ICP token, and it has several major uses. Firstly, it acts as a governance token, so you can lock up your ICP, and then in exchange for doing that, you can take part in the governance process that happens in the network nervous system. For example, you can put up proposals, or if someone else puts up a proposal to change the network, you can vote on that. ICP is also rewarded by the network to participating data centers for good behavior, and you also use ICP to pay for transaction fees on the network. Now, as for supply changes, there are both deflationary and inflationary mechanisms. So when it comes to deflationary mechanisms, basically anytime someone launches a canister / an application, they will need to pay for storage and compute, and they'll pay so using the ICP token. And when they do pay for those things, those ICP tokens will just end up getting burnt. So the more applications and the more canisters there are on the network, the more burning will occur for the ICP token. But alternatively, you also have some minting mechanisms as well. So people who take part in the governance system will receive voting rewards, and those rewards will come from newly minted ICP. And on top of that, people that do run those data centers running the network will also receive newly minted ICP for rewards as well. Overall, this has led to an inflationary network. So the total supply at launch was 469 million ICP tokens, and it is now sitting at 515 million ICP. And the network launched in 2021. So it is inflationary, but in my opinion, not by a much, and it's not really something I'm worried about. And who knows, the more applications that do launch on ICP, the more we could see inflation potentially go down. Okay, so general overview done. Let's now get into the FUD surrounding the Internet Computer, because the Internet Computer is honestly one of the most hated projects in crypto. So does it actually deserve that hate, or are all the haters lying to you? Let's get into it. Quick tangent before we head back into the video to remind you that you can claim over 6 figures in US dollars incredibly easy by signing up to the exchanges in the description down below. We have Bybit, which is one of the largest exchanges on the market, BingX, which is supported by the Chelsea football team, and yeah, just simply sign up and deposit to either one of them or both of them, and boom, claim tens of thousands of US dollars. This is not a joke, this is real. The number one point of FUD the Internet Computer has is that it is just centralized garbage. And that's because a lot of people say that you can't run a node if you're a normal person, as the network only allows for data centers to run nodes. And they're not actually wrong. You do need to be a massive data center to become a node on the internet computer, but that doesn't mean it is completely useless and centralized garbage. In fact, the actual point of the internet computer is to serve purposes that very decentralized blockchains like Ethereum can't already do. A lot of haters for the internet computer, and also a lot of community members who just don't understand how it works, keep comparing Ethereum to the internet computer when it comes to scale and decentralization. Take it from the CEO of the internet computer, Dominic Williams, when he says the internet computer is not and was never intended to be, nor has ever been sold as an Ethereum killer. Ethereum and the internet computer are different beasts, which derives from their respective focuses. You cannot transform one into the other owing to technical considerations. They are different by design, but very complementary, not competitive. The internet computer is hosted by special node machines run by independent node providers in independent data centers around the world. By contrast, anyone can create a block-making Ethereum node using a graphics card. And the key here that a lot of people are missing is that you need both Ethereum and the internet computer to create the full Web3 stack. So Ethereum is very good for the mission critical part of a decentralized application. So when it comes to Uniswap, the actual smart contracts that do the swapping of the tokens, Ethereum can do that just fine, especially now that layer 2s are out and they are helping to scale Ethereum. But because Ethereum is still insanely focused on building a decentralized platform, they simply can't do things that involve more storage and more computation than those simple applications. For example, once again, you just can't create a decentralized website on top of Ethereum. So all the Ethereum applications are having to use centralized websites. You can't use Ethereum to do massive computations for things like AI as well. And that is basically just the use case of the internet computer. It comes in and fulfills all of those things that very, very decentralized platforms like Ethereum can't do. And that is what a lot of people just don't get, and what Dominic Williams was getting at in this Medium post. The internet computer was not designed to be as decentralized as Ethereum. It was designed to be a bit more centralized, but in doing so add much more functionality and fill in those gaps that Ethereum couldn't do, such as hosting more decentralized websites, etc. So I think of the internet computer as sitting in between Web 2, Amazon Web Services, centralized applications, and Ethereum, Bitcoin, really decentralized chains. It sits in the middle and then does the things that Ethereum and Bitcoin can't do for it. So the FUD about the internet computer being centralized just doesn't make sense to me, because it's clear it was never supposed to be as decentralized as Ethereum. The next big point of FUD is the controversial launch of the ICP token, which in my opinion is actually valid FUD. This is the initial token distribution at launch, and if you look closely, 0.8% went to the public/community. 99.2% of the entire supply went to hand-picked insiders. And this is very bad for any cryptocurrency project, especially ones like the internet computer that have a governance system. Basically, your entire governance system is now captured by insiders, since they have enough tokens to just vote in whatever they want to vote in. The public/community has no say in it. Now, there is a silver lining, which is that the price of ICP has gone down a bunch, and it's already been out for 2 years, so it is very possible, in fact likely, that a lot of those insiders sold a lot of their tokens during the last 2 years, especially once again whilst prices were way higher than they are today. And if they did sell a lot of their tokens, it could mean that the supply distribution between the public and insiders these days is a lot better. Not only that though, but the circulating supply compared to the total supply is very, very good. A lot of these newer gen projects like Arbitrum/Optimism come out with a very low circulating supply, and VCs and insiders just end up dumping on them and suppressing the price. That can't really happen with the internet computer because most of the tokens are already tradable. On top of that as well, yes, I'm not a fan of the centralized tokenomics for a decentralized platform, but honestly, if you compare it to a lot of the platforms out these days, this is Solana's token distribution, it's not too different. They're all coming out with centralized tokenomics, and with Solana being number 5 in terms of market cap, it's clear the market doesn't really care. Maybe long term, people will start caring about true decentralization, but in the next 1 to 2 years, as the bull market is coming along, it seems like people just care about having a nice platform that's lightning fast, that can do what they want it to do, and that provides an amazing user experience, which in my opinion, the internet computer does do at the moment. Okay, the internet computer versus its competitors. Now, yes, the internet computer can do much more than Solana. You can actually do true compute, true storage on the internet computer that you can't do on Solana. You can build more complex applications on the internet computer, but right now, one of the biggest use cases is simply simply just having a nice user experience to trade meme coins on. And yeah, in that massive use case that we're seeing at the moment in crypto, Solana is the #1 competitor. So if we do compare the stats real quick, Solana has an average of 5 seconds to reach finality, with outliers going as far as 12 seconds. And Solana can do around 50,000 transactions per second max in its current build. If we do compare that to the internet computer, there is no real TPS limit on the internet computer. Once again, I just described how the internet computer can always just add more subnets, and its finality is also way faster, so it has a web speed finality of 2 seconds. And the amount of blocks per second the internet computer has is pretty insane. So Solana has 2.5 blocks per second. The internet computer has almost 10x that, 22.5. Out of all the major blockchains right here, I do think the internet computer is basically the most scalable and the fastest. Now, when it comes to full-on DPIN, I believe the largest competitor the internet computer has right now is ARWEAVE, and I recently did a video on ARWEAVE as they recently released a massive hyper-parallel computer on top of their chain. Now, ARWEAVE is very interesting because they found a way to do permanent information storage. You pay once and your data is never deleted, and currently the internet computer cannot do that. And they also found a way to make their chain basically infinitely scalable when it comes to storage and TPS as well. And they recently came out with this AO computer update that uses that infinitely scalable layer 1 to build an infinitely scalable world computer on top of it. The general gist is, because ARWEAVE has this infinitely scalable layer 1, what you can do is have computers perform tasks, and then every now and then the important information from those tasks or processes are sent to the ARWEAVE layer 1 to be stored. And because that happens, you can just verify whether or not the tasks were done correctly. And because you can store basically an unlimited amount of information on top of ARWEAVE, you can just have as many of these computers constantly sending information to the ARWEAVE layer 1 to verify their compute. Now, this is very good because it allows for complete customization, something that the internet computer doesn't currently allow for. So instead of enforcing one set of choices upon all users of the computing environment, AO is built in a modular form, allowing users to choose which virtual machines they want, sequencing models and message passing security guarantees and payment options work best for them. But one big plus the internet computer does have is the amount of memory that are allowed for smart contracts. So at the moment on ARWEAVE, they are limited to about 4 gigabytes of memory for contract storage. The internet computer has a much higher roof for that, meaning that for more data intensive applications, it could be better to use the internet computer. So for things like AI, I believe it may still be more efficient if you are to build that on the internet computer right now. The internet computer also has a bunch of nice features built in, such as a custom HTTP gateway, which I believe once again allows you to easily just host your own decentralized websites. Another big advantage the internet computer has is network effects. It's already been out for years now. It already has a strong ecosystem on top of it that is growing rapidly. And those network effects, even if there are slight differences in the way AO and the internet computer work, might just be the key to winning this. People may just choose to use the most popular platform instead of using a slightly different platform that is less popular. And on top of that, because the internet computer is more matured, AO is still, I believe, in beta, it hasn't even been released yet, then there's a decent chance this just works more smoothly than the AO framework. They've probably worked out a bunch of the hiccups with the internet computer in the early days that the AO computer will probably start dealing with, because once again, the AO computer is still in its early days. So for a more well-rounded solution that works today, I think the internet computer wins, but in the long term, I think the AO computer could be a pretty big competitor, at least for certain types of applications, especially if they do require permanent storage, which once again AO computer offers natively via ARWEAVE. Now, if I'm honest, this is starting to get a little bit out of my depth here just because of how technical it is getting, but I will leave this amazing comparison in the description down below. So if you do know a lot about the technicals, you can take a look at this right here, and it should give you a decent idea as to what the true differences between AO and the internet computer are. Now, another major DPIN project is FILECOIN, and shout out to Virtual Bacon because he managed to get this chart right here, which I think is very, very amazing, and he has one of the best descriptions between all of these 3 major projects. So definitely check out his videos if you haven't already. This chart just goes to show as well the limitations of FILECOIN. So this is a bit outdated. ARWEAVE technically has all 4 of these green, just like the internet computer, but FILECOIN, the other major DPIN project, you can't really build true backends on top of it. So FILECOIN is not a true full stack solution like AO/ARWEAVE ARWEAVE and like the internet computer. So in my opinion, it's already not really winning this race. Moving on to the ecosystem on top of the internet computer. Is it good? Is it bad? Currently, it has a total value locked of $33.82 million US. And yes, it has started to grow parabolic, but that is still really low. So its DeFi ecosystem is pretty bad. But because the internet computer is more than just a normal layer 1, you can't just use TVL to measure usage. This is a deep-in project and can be used for a lot more. So another good metric to take a look at is the average cycles burnt. This metric is more or less the equivalent to just people paying for Amazon Web Services. So this shows true network usage in my opinion. Now at the start of January 2023, there was on average 331 trillion cycles per day. And this increased to 734 trillion in December, a 121% increase throughout 2023. So the internet computer is definitely growing in usage, but honestly, it's still hard to determine how much usage that actually is in comparison to other chains, because no other chain uses that metric. We can use transactions per second. The internet computer does about 5,000, Solana does about 2,400, but even that is still pretty bad at comparing because we don't truly know what goes into each of these transactions. Maybe because the internet computer is structured differently, these transactions mean less. Maybe there's a really inefficient application on it that is using way more transactions than it needs to, etc. What I will say about the applications on top of the internet computer is they have some really cool ones. So we have this one right here, DSCVR, which is an end-to-end decentralized Web3 social media platform. Full decentralized website and full decentralized backend. That is something I believe people have been waiting on for a very long time, and the internet computer has it completely running just fine on its network. That is very cool. But yeah, it is a shame I didn't find a way to truly compare its usage to any other platform, so let me know if you have any better ideas as to how to do that in the comments down below. So where is the internet computer heading in the future? Well, the biggest upgrade I see for it is the fact that they are now pivoting to be more AI friendly, and I believe AI will be absolutely massive in the crypto world. Reminder before we get back into the video that there's literally zero reason as to why you shouldn't sign up to these top exchanges and claim over 6 figures in bonuses. So on your screen right now, you can see Dominic Williams showcasing an AI demo where they put a picture up and an AI running on top of smart contracts on the internet computer basically tells you what is on that image. So this announcement was made on March the 21st, and yeah, it says that the code for that AI will follow shortly. I believe it is already out, and that this entire AI is running on the internet computer testnet, but that you'll be able to run this on the public network as soon as an upcoming update comes to the network, which should come in the coming days after this post, which I believe has already happened. Some important notes on this AI: the inference engine has not yet been optimized, and we will show vastly greater efficiency in subsequent demos where the AI runs even faster and consumes less gas/cycle. So in the demos, it took about 10 seconds for the AI to recognize each picture, and they plan on having that sped up massively. The team will also propose to the network nervous system that smart contracts have access to SMID instructions, which we have determined are deterministic, unlocking vastly more speed and efficiency for AIs. Lastly, currently the active smart contracts ICP hosts run inside a 32-bit environment, which limits their main memory to 4 GB. Within the next couple months, they expect that the internet computer will move to a 64-bit environment, allowing smart contract memory limits to be raised much higher, allowing for models with far more parameters and thus power to be ran. Now, this next part is what really excites me for AI on top of the internet computer. So they plan to propose a new public node machine specification, which node providers can build to for use in subnets specialized for hosting AI smart contracts, in which each machine will incorporate several GPUs. Naturally, this will be packaged with other technological developments that ensure smart contract determinism. GPUs are the main hardware components that AIs really do need to run, so this is a fantastic update. And this is part of their mission to enable powerful large language models to run as smart contracts on the internet computer in a form that is completely tamper-proof, unstoppable, and optionally autonomous. We've already seen decentralized GPU platforms such as Render explode in terms of price just because of how hyped AI is, and it's great to see that the internet computer is now joining that race. Final thoughts: I do believe at this current date and time, the internet computer is the best full stack Web3 solution on the market out there. So I believe it is the best deep in solution on the market. The one true competitor I see that it does have is the AO computer, but the AO computer on top of ARWEAVE is still incredibly new, and the internet computer computer is just a more mature solution. You can actually build a full stack solution on the internet computer today, right now. So it does have the added benefit of being a first mover, and it does have the added benefit of those network effects. There are way more people building on top of the internet computer than currently on AO. And is everyone lying to you about the internet computer being centralized garbage? Well, yes, the internet computer once again just wasn't built to be as decentralized as Ethereum. It was built to be a little more centralized so that it can add so much more functionality and basically complete the parts of the Web3 stack that Ethereum couldn't complete, such as building website front ends, having a bunch of compute to do more complex applications, etc. Okay, now let's get into my predictions for ICP. And once again, I'd like to reiterate that this is not financial advice. I don't have a crystal ball that tells me exactly where these coins are heading, so I could be completely wrong on this. Keep that in mind, not financial advice. So with that said, I believe the internet computer has easily top 15 to top 10 potential, simply because it is the best Web3 full stack solution on the market. And just comparing the usefulness of ICP to some of these other projects, I just think ICP sounds way more exciting than something like Polygon/Matic, which is literally just an Ethereum sidechain. I mean, why do we even need this with layer 2s in the picture right now? If we go up, we have Polkadot, which also doesn't really have a strong ecosystem. I also did a video on Polkadot, and honestly, I don't really see too many bullish narratives coming out for this chain. I think there's a decent chance this does also start to become pretty irrelevant. Cardano as well. Basically, no one uses this coin, let's be honest. It is kind of a ghost chain, yet it's sitting at the top 10. I mean, just take a look at these other projects. I think the internet computer wouldn't find too much of a hard time moving up into the top 15. As for breaking into the top 10, I wouldn't be too surprised to see the #1 DeepIn project do that, but what I would really like to see from the internet computer is its AI endeavors really going successful. I think there's a decent chance that the top AI cryptocurrencies could start to occupy the top 10 just because of how big of a narrative AI is. The internet computer so far is a little bit behind when it does come to AIs. They are just making these updates or just announcing them. So yeah, it will be very interesting to see where they go with AI. If they do play their cards right and they do become a central powerhouse for decentralized AI systems, then I do think top 10 is warranted. If not, then it may be much harder to break into that top 10. Like and subscribe if you enjoyed an honest review of the internet computer. Let me know what you thought about ICP. Once again, take advantage of the 6-figure plus in bonuses in the description down below. There's no reason this bull market why you shouldn't be claiming thousands and thousands in free rewards. Join my free Discord for more, and I'll see you soon.